So let's start the session. So this is week 7 online live session for the NPTEL course on Urban Utilities Planning, Water Supply, Sanitation and Drainage. So the course is offered by Dr. Devapratim Pandit. He is a professor in Department of Architecture and Regional Planning at IIT Kharagpur. I am the teaching assistant for this course. I am Vaibhav Kabadwal. I am a research scholar in the Department of Civil Engineering at IIT Madras. So we will be studying about sanitation and drainage in this lecture. We will solve some MCQ, fill in the blanks and numericals and a few match of the following. And so far we have discussed about water supply, and in this lecture we will try to understand about the treatment of wastewater, means sewage from the households. So let's have a recap here. So from source, we took the water and we gave it to the, we supplied it to the community. This is called water supply. And from community, if we are directly or indirectly we are supplying it to the source. So this is wastewater. And here also the treatment is required. Some treatment. Here also some treatment is required. We can understand it in terms of a river. So we already discussed, I think. So here we have a river. We have household here. So they will supply, they will take the water first of all from intake structures and all. So the water is to be supplied, but before supplying we are also doing some treatment. It's not just supply. So we are taking the water, we are treating it, we are calling it water treatment. And then after that we are supplying it to the household or a whole community. So this whole community will generate wastewater. And that wastewater we can't directly dispose it. So we will treat it in a wastewater treatment plant. And if the effluent meets the discharge standards, then only we can discharge it. So this is the scenario. So but the treatment plant is not every time required. Let's see. So the treatment plant is not every time required. It depends on population, upon the population density. depends how what is the distance between the homes. In the house. Based on that, we will decide what type of sanitation system is to be used. So, what are conservancy system, on-site sanitation system, decentralized sanitation system, water carrier system? So, in conservancy system, manual scavenging was done. These were practiced earlier. So, where manual handling was done. You can write manual handling. So it has to be avoided. So in on-site sanitation system, so treatment was done at individual household level. So a septic tank is the example of septic tank, leach pit, along with soak pit. So these are the examples of on-site sanitation system. And in decentralized sanitation system, for a if these are provided when density is less or low density areas. One thing is that. Second thing, if we want to reuse the water, our objective is to reuse the treated water. Treated water. So the water can be reused like for flushing, for public use, and it can be used for gardening if it meets the standards. So then decentralized system can be utilized or used because the length of pipelines will be small, so that there is less cost of pumping. It saves pipe length and pumping cost also. Decentralized system treat, reuse and disposes sewage near to its source of generation. So the sewage is not carried in a very long sewer pipelines, rather than the sewage is treated near the source itself. So like we can say for a small community we have one treatment system. This is decentralized sanitation system. And even though there is no discharge facility, we can reuse the wastewater after the treatment. So this is the objective. And in the water carrier system, the pipes are used or sewers are used to carry, which will carry the wastewater to the sewage treatment plant, where it can be treated easily. So now we will understand about the types of solids. So after that, we will we will study about the sewage treatment facility. So we have two types of solid in water. These are inorganic solids. And another one is organic solid. These solids can be divided into two. For the two parts, inorganic solids can be dissolved. Inorganic solids suspended in organic solids. Organic solids can be divided into two parts. These are dissolved organic solids and suspended organic solids. So here we have seen the water which we are taking from river for the treatment, that has very less amount of in water treatment. Organic solids are very less. Example, in general, in general, but not always. So if water is taken from a river which is less polluted, it will contain very less amount of organic solids, both in suspended and dissolved form. So in that case, so in case of water treatment, these solids are dominant. Inorganic solids are dominant. Dominant in the case of water supply. And whereas these solids are dominant in case of wastewater treatment. In case of sewage treatment, we can say. So here we can say wastewater or sewage. So we have to remove dissolved organic and suspended organic solids. Existing sewage treatment facility. So how to remove those dissolved organic solids? Let's understand this all. So we need to remove the organic solids which are dissolved and suspended. They can be removed physical by settling, but that can remove only suspended solids through chemical means coagulation, flocculation, and sedimentation. It will remove. It can remove suspended solids plus dissolved solids. Part of these are the part of organic solids. Whereas, but may not be economical because of chemical cost. So we have one more treatment method that these are called biological methods. Biological methods that we'll also understand. So in biological methods of organics removal, what happens? Microbes utilizes organic matter and multiplies. Organic matter means mostly dissolved organic matter. Dissolved, biodegradable, dissolved, biodegradable organic matter. So utilize microbes utilize organic matter and multiplies and they grow. And this organic matter is mostly dissolved or dissolved biodegradable organic matter. It can be suspended also, but it will take more time. So microbes can eat suspended also, but suspended can be easily removed in the sedimentation tank, and they can be removed. So that's why we prefer uh, dissolved organic, dissolved biodegradable organic matter to be consumed by consumed. So that's why the dissolved biodegradable organic matter is consumed by the microbes, and due to that, if it is aerobic reaction, if it is aerobic, it will consume oxygen and will produce CO2, and so and the organic matter will be oxidized to CO2, and it will grow, and it will grow in numbers, and it will form the colonies, and that can be settled in the secondary sedimentary tank, that we will understand later on. That we'll study here. So from this sewers, from this sewers, the sewage is being carried, and after being carried, it will pass through the bar screen. So the bars are used; these are the coarse screens. So these bar will remove the floating materials, cardboard and all. These will floating materials. I will write floating solids, and the floating materials are removed here. Then we have some less small size solid particles. So if they are organic, they will have less density. If they are inorganic, then they will have more density. So the inorganic solids, suspended solids. Inorganic suspended solids are removed in the grid chamber. The water will be passed through this to this in this length in 1 to 2 minutes. So uh, the detention time of grid chamber is provided approximately 1 to 2 minutes. So the heavy like sand or grit particles are removed in the grid chamber. After that, the water is passed to the primary clarifier. In the primary clarifier, the uh, organic suspended solids, organic suspended solids are settled, and this will form sludge at the bottom. Let's take like this. This is primary sedimentary tank, primary clarifier. So it will form sludge at the bottom. So that sludge is transferred to the is first is transferred to the sludge digester, and then it will be dewatered. So that we'll understand about the sludge digestion in the later part. So after the primary clarifier, only dissolved suspended solids are will pass through in this fluid. So it will contain dissolved organic and dissolved inorganic. But inorganic portion is comparatively less, so we'll treat it for dissolved organic part. So this flow line will contain dissolved solids. Whatever process I discussed earlier, so the microbes are contacted with the dissolved organic solids, or we can say dissolved biodegradable organic solids in the aeration tank or trickling filter. So aeration tank is a suspended root system, whereas trickling filter is attached root system. So they will come in contact with each other. Microbes will degrade or decompose the organic matter, and they will oxidize the organic matter to carbon dioxide in presence of oxygen if it is aerobic process. So these two are aerobic processes, and the organic matter, or we can say BOD of the effluent will be reduced, and we will get the more microbial mass or cells. This microbial mass is then taken is will come out in this effluent, and we'll transfer that effluent to the secondary clarifier. So in the secondary clarifier also same thing will happen whatever happened in the first primary clarifier, but in a bit different way, because the type of biomass because the type of sludge is different in the secondary clarifier. So type 3 and type 4 type of settling is observed in secondary clarifier. So from the bottom of the clarifier, the sludge is taken out and then sludge is transferred to the thickeners. After thickening, then it is again digested because it will contain microbes. This will contain microbes, this will contain organics. So both are brought in the sludge digester unit, where the sludge is digested and the sludge will be converted into gas, uh, some liquids, and some further solid part is also formed. So in the supernatant, it's a liquid which is floating or at the top of the sludge digester. So that will also contain some COD, BOD. So that is again recycled back for the treatment. And this sludge, the digested sludge, is called digestate, and this digestate is again dewatered, and then after dewatering, whatever the concentrate or liquid which is formed or liquid produced out of this, that will also contain some COD or and BOD. So that is also again recycled back for the treatment. Remember one thing. So the recycling here is only for the treatment here also. So after thickening also, the liquid which is uh, produced or generated, that will also contain uh, organics. So that's why it is again recycled back so that it can be treated further. So that this is the only purpose here. But if we see in detail in aeration tank and in trickling filter, the purpose of recycling is different. So in the sludge digester, yeah. So after dewatering, we will get the solids. These solids are inert in nature now, and these can be either landfilled or can be sent for composting. And if they have good heating value, they can be used for incineration. So after the secondary clarification, we will get the effluent which has less COD, BOD, and less nutrients. So then we can treat, but it may contain some active microbes. So we can treat it with we can disinfect it with chlorine and other methods of disinfection. And after this, we can treat the this treated effluent can be discharged either into the river or any water body, and this water can be utilized further for uh, uh, this water can be recycled or reused for the tree for the any let's say flushing. It can be used for flushing or public use, that like that we discussed in the decentralized treatment. So for that all for this small for this purpose, like flushing and water for actual public use for gardening, it can be used. So this was about the existing sewage treatment facility. So this combined, what is the meaning of this term combined sewage? The combined sewage refers to residential discharge from latrines and urinals, sewage recently originated, sewage undergoing treatment, combination of sewage and stormwater. So one thing we can include is, so we understood it like this. So here we told this is the community. So if it is paved, from rainfall also it will generate. Rainfall will also occur. So rainfall will also occur. So if the rainfall water joins these sewers, if rainfall water or drainage, rainfall water which is if rainfall water joins this sewage, then it is called combined sewage system. If rainfall water separately taken to the with drainage, if it is separately taken to the river or separately it is actually utilized for the rainwater harvesting, then this is called separate sewerage system. Here we can say, so this is called combined. This is, in combined sewage, it is the combination of sewage and stormwater. So the stormwater is nothing but rainfall. Rainwater is from the rainfalls. So the combination of sewage and stormwater. Fresh sewage refers to the sewage recently originated. Combined sewage refers to the combination of sewage and stormwater. Sludge indicates the wastewater from bathrooms and kitchens. Sludge will not contain from toilets. The underground conduits and drains which carry the sewage are called. These are called sewers. Sludge is a term for the bathroom and kitchen waste. And sanitation is which we are studying. Vent pipe are the pipes for carrying the air, for releasing the air actually. What is the design period for non-conventional sewers such as small bore, shallow sewers, pressure sewers, vacuum sewers, etc. in years given by CPH computer? The answer is 15 years C. So the design period for non-conventional sewers is 15 years. The optimal pit emptying frequency of a leach pit is. So the optimal pit emptying frequency of a leach pit is 1.5 to 3 years. Up to 3 years. Match the following. According so yeah, in the Swachh Bharat mission, there were the objective is to eradicate the open defecation. So there were three objectives: ODF protocol, ODF plus, and ODF plus plus. So we have to match this with protocols with the description. So in ODF protocol, so we'll go one by one. So not even a single person is found. So this looks easy. Not even a single person is found defecating in open during any time of the day. This was A. So not even a single person is found defecating in the open during any time of the day. Not a single person is found defecating or urinating in the open during any time of the day, and all community and public toilets are functional and well maintained. Correct. So this was B. Fecal sludge, septage, and sewage is safely managed and treated with no discharge and or dumping or treated fecal sludge and sewage in drains, water bodies, and open areas. This was first. So in first they talked uh, about only open defecation, not about urinating, not about urinating. In second they talked about open defecation, no open defecation, no urinating at any time of the day, and the public toilets should be functional. And in the ODF plus plus, the sewage or the sludge septage which is generated, that should be safely managed and treated with no discharge or dumping of fecal sludge into the drains or through drains into the water body or any open area. So these were the three protocols of Swachh Bharat Mission. So A2, B3, C1. So the answer is D. The answer is D. Major goals of National Urban Sanitation Policy. So the goals were awareness generation and behavior change. Second is open defecation free cities. So there should be no open defecation. Access, that means, so the sub objective is access to safe sanitation and waste disposal facilities for households, community planned and managed toilets where necessary, adequate availability and 100% upkeep and management of public toilets. So the public toilets should be maintained also, apart from providing, that should be, they should be maintained. Integrated city-wide sanitation. So mainstream thinking, planning and implementation, strengthening the national, state, city and local institutions, sanitation facilities for poor communities and other unserved settlements. What are the key points of prohibition of employment as a manual scavengers and their Rehabilitation Act? So this act was for the employment of manual scavengers and their Rehabilitation Act. So it tells that to prohibit the manual cleaning of sewers and septic tanks. So manual cleaning should be prohibited. And elimination of insanitary latrines to twin pit pore flush latrines. So these are twin pit pore flush latrines. So in this what happens? If one only once is operational at a time, so if gets filled, it will be not used for around 2 years. So that into these 2 years, and the volume will reduce, it will get digested, and after that, it is again reused alternatively. And third point is rehabilitation of manual scavengers in alternative occupations. So you have to rehabilitate the manual scavengers in the alternative occupation. So we here the third point is talking about giving the employment in a different field. Which of the following parameters constitute the concept of totally sanitized cities? Which of the following parameters constitute the concept of totally sanitized cities? So this concept will includes open defecation free, municipal sewage and stormwater drainage, recycling and reuse of treated sewage for non-potable applications, and improve public health outcomes and environmental standards. So it will contain all the 4 points. What is use of water seal in the toilets? The seal is provided at the end of the toilets. So this is called water seal. So this much water is contained. Here it is disposed, so the gases may come out. These are gases. So the gas can't pass this water. So it will reduce the order. So in this combo, this is the water seal. It will prevent the flow of gases through this pipe, through this water seal, and the gas will not pass through it. And instead of for passing the gases, we provide the vent pipe. Likewise, we can prohibit or we don't allow the uh, passage of gases into the uh, into this room of to this room. So it prevents entry of gases, hence unpleasant odors are avoided. What is leach pit? So this pit allows liquid waste to percolate into the surrounding soil, while solid waste is contained within the pit. So the sewage is discharged into the pit. So this water will percolate and solid will remain here. Groundwater table above bottom of pit is called the groundwater table. This is ground. This is groundwater table. If the groundwater table above the bottom of the pit, this is the bottom of the pit. So this is called wet pit. Groundwater table above the bottom of the pit is called dry pit. Type of digestion carried out in septic tank. So in septic tank, anaerobic digestion is carried out because the presence of oxygen is less, and so that's why it is anaerobic digestion. What are the factors to be considered for soak pits and dispersion trenches? So for these two, percolation rate is should be below 25 minutes per centimeter. So for flowing 1 centimeter, it should take less than less than 25 minutes. And depth of water table. So the depth of water table should be more than 2 meters. This depth should be more than 2 meters. Greater than equal to 2 meters. These are the two requirements of soak pits and dispersion trenches. How to calculate percolation rate in soak pits or dispersion trenches? So how to calculate percolation rate? So percolation rate is uh, we can say it like hydraulic conductivity. So at what rate the water is flowing in the soil. So this is called percolation rate. How to calculate? So it can be calculated by, it is determined by excavating a hole to a depth of excavating a hole up to a depth of trench of the trench. So this is the trench. So same depth up to the depth of the trench, measuring the fall in level. So we'll fill it with water, or we can fill it with sewage. Maybe we'll check the fall of 1 centimeter. So how much time, and you will make the and you will measure the time. So how much time will it take? So that time will tell us the percolation rate, and this dia can be 10 to 30 centimeter. So that this T will be only time, but this time is the time is for drop down of water level, the drawdown of water level by 1 centimeter. What is the difference between soak pits and this dispersion trenches? So in the dispersion trenches, only area of trench bottom is considered. So the bottom area is only considered, or the leaching. Whereas in the soak pits, side area is considered only. This side area. If it is cylinder, the cylindrical this side area is only considered. bottom area. The mixture of liquid and sludge is referred to as dash and has high VOD load. The mixture of liquid and sludge is referred to as septage and it has high VOD load. So, in the previous slides, this septage is being added at different locations S1, S2, S3, S4, S6. So here we can understand one more thing. So this whole flow chart, this whole flow scheme is for centralized systems. And currently we are studying about septic tank, leach pits, soak pits. These are on-site treatment facilities. So from the on-site treatment facilities, this sludge is getting produced, and this sludge can be added to the centralized facility. And this centralized facility, if it can take the load, then if it can take the load, we will supply or we will discharge the septage to these different locations, and then if we can discharge them at S1, S2, and S4 to S6. So if the septage can be discharged at these locations, and if the treatment plant is designed to take such load, then treatment of on-site, then the treatment of septage can be done, and the treatment, and this is the ongoing treatment facility which is already designed. So simultaneously, the septage can be treated in the centralized facility. Which of the following uses metal tank filled with concentrated solution of caustic soda? Which of the following uses metal tank uh, with a concentrated solution of caustic soda? It will contain it is in chemical toilet. Which of the following unit is not a component of decentralized wastewater treatment system? Leach pit is a part of leach pit is a part of on-site sanitation system. Pre-treatment settler is a part of decentralized system. Anaerobic buffers tank reactor are also the part of decentralized wastewater treatment. Polishing pond after the secondary treatment, treatment can be used as a tertiary treatment unit. Can use as a tertiary treatment unit. So, which of the following unit is not a component of decentralized wastewater treatment system? The leach pit is not the part of decentralized wastewater treatment system. Which is the minimum number of What is the minimum number of dispersion trenches to be provided if area required for dispersion trenches 70 meters square? Area required is 70 meters square and the width of dispersion trench is 1 meter. So length into width is area, that is 70. So length will come under 70 divided by 1, that is 70 meters. So but length cannot be more than 30 meters. So we will so in question it is asked how many numbers of dispersion trenches. So one dispersion trench can only have length of 30 meters maximum. So if we divide 70 by 30, so we will get 2 point something. Point something. Then so we'll take it as 3. How much we are getting? Let's calculate. 33. Take 3. So 3 numbers of dispersion trenches are required. Answer is 3. So determine the area in meters square required for dispersion trenches for the disposal of septic tank effluent for a population of 100 and sewage flow is this much. Consider the percolation rate is this much. So we have this charge is 100%, 130 LPCD. So 130 13 into 10 to the power 3 liter per day. This much is required. And we have one more formula is percolation rate is 130 under root T. The percolation rate is 4 minutes. So T is 4 here. So 130 into 2, that is 260 liters. The unit is liter per meter square per day. Or we can write it as liter per day. So we need to find the area. So we can divide this 13 into 10 to the power 3 divided by 260. We'll get it as 20. So it will be 15 meters square. Let's check it. Answer is 50 meters square. Which of the following statements are true for upflow anaerobic filter? So upflow anaerobic filter, so it is suitable for areas where leaching systems are not effective for effluent disposal. This is correct. Where leaching is not, because we have studied just a few minutes back that for soak pit for there are two factors. For soak pits and dispersion trenches, the percolation rate should be less than 25 minutes. The percolation rate should be below 25 minutes, and depth of water table should be 2 minutes, 2 meter or more. So this water table should depth should be more than 2, either 2 or more than 2. So then only we can provide the soak pits or dispersion trenches. So if this condition is not available, then we can go for anaerobic digestion, this upflow anaerobic digestion, anaerobic filter, anaerobic filter. If no, not satisfied, not satisfied. Then we can go for anaerobic filter. So suitable for areas where leaching system are not effective for the effluent disposal. So correct, we will go for an upflow anaerobic filter can be constructed only as a separate unit and not as an extension of the pit toilet. No, we can use the anaerobic filter as an extension also. So this is wrong. Effluent is introduced from the top. No, actually, effluent is introduced from the bottom, so that's why it is called upflow. So from bottom it is introduced. That's why it is called upflow. Effluent has high volume of the sludge. No, it has very less volume of the sludge because anaerobic bacteria have very less growth. They are slow growing bacteria. So it will have less sludge because of the anaerobic process. Anaerobic process, if you compare it with aerobic process, will give you less sludge because of the less because anaerobic process is slow and it takes uh, more time. So the growth is so less microbes or less sludge is produced in the anaerobic processes. Which of the following statement are true for anaerobic bacteria? So this is the same question. So it is suitable for areas where leaching systems are not effective for the effluent disposal. So where leaching system is not effective, that we discussed. Secondary treatment of septic tank at low cost. So the secondary treatment of the septic tank at low cost can be done. Suitable for areas where leaching system are not effective. It is used where leaching system is not effective. That we discussed, like whether if the soil is dense soil, then it has high water table, means water table near the ground itself. So there we can use the upflow anaerobic filter, and it is constructed as both separate unit or as an extension unit. So it can be provided as individually or as an extension of septic tanks. Effluent is introduced from the bottom that we discussed. From the bottom we'll introduce the effluent, so that's why it is called upflow. Effluent is clear and free from the odor. So the effluent is clear and free from odor, and it is low volume in sludge because it is anaerobic process. Because it is anaerobic process. And anaerobic process, the sludge production is very less. And from this anaerobic filters, the product will be methane. Anaerobic processes will produce methane, and methane can be utilized for its calorific value. So it can be used as a fuel. And the sludge can be dried, and that can be again processed. And the sludge can be dried, and then it can be used in the fields as a fertilizer. So this was about the today's session. Thank you.